Okay, so we're going to do question 5.21. So it's giving you a utility function u as a function of s and t, and that just equal to s squared and t squared. So it's telling you the marginal utility for root s and root t. Okay. Now, so instead of using whatever is already given you in the textbook, I'm just going to show you how do we find the marginal utility. So just basically a practice of how do we differentiate a utility function with respect to one variable, which is called a partial derivative. Okay. So in order to find a marginal utility of root s, what we do is we differentiate a utility function, okay, with respect to that root, so with respect to s, treating t as a constant. Okay, so we're treating t as constant, and we differentiate the utility function with respect to s, and that is going to give us a marginal utility of s. So marginal utility is basically just an extra utility that a consumer can get by consuming an extra units of root s. Okay, so this is called a partial derivative. So if you differentiate this utility function over here with respect to s and keeping t constant, now so we're treating this t squared over here as a constant. So when you differentiate a function, the constant will remain the same. Okay, so it's just going to be staying there the same. This is a function we differentiate with respect to s. So our function is s squared. When you differentiate that, it will become 2s. Okay. So this is our marginal utility of s, which is what you are given in the textbook. Okay. So if you are going to do it exactly the same thing, you differentiate a utility function with respect to t, treating s as a constant, then you should be able to find a marginal utility of t. So if we're treating s squared as a constant, then it will remain the same here. And if you differentiate t squared function with respect to t, then you get 2t. Alright, so part A of the question asking you to show that if t equal to 1, then the marginal utility of s is increasing in s. Okay, so if t equal to 1, then the marginal utility of s is going to be equal to 2s. Okay, and so as you can see, obviously whenever s is increasing, marginal utility of s is going to be increasing. Okay, so therefore we say that the marginal utility of s is increasing in s. Okay, or another way to do it mathematically is if you differentiate the marginal utility function over here with respect to s, and if you have a positive number, then we say that the marginal utility function, marginal utility of s is an increasing function of s. Okay, so either way is fine. Now this is the obvious case where by just looking at it, you can tell that whenever s is increasing, marginal utility of s is increasing. Okay, so you do not need to differentiate or to find a derivative to confirm that the marginal utility is an increasing function of s. But if you are having more complicated function where it's not possible to just tell by just looking at it, then you will have to differentiate and prove that your derivative is positive in order to confirm that the function is increasing in the variable. Okay, so in this case, as s increasing, we can see that marginal utility of s is going to be increasing. Okay, or if you want to differentiate the marginal utility of s with respect to s, then you get 2, which is positive. So then we know that the marginal utility of s is increasing in s. Okay, now it's telling you the second case is if s equal to 2, they want us to show that marginal utility of t is increasing in t. So if s equal to 2, marginal utility of t over here is going to be equal to 2 squared, which is 4. times 2t, which is 8t. Okay, so again, it's very obvious to see that whenever t is increasing, marginal ut of t is also increasing. Okay, it's just obvious from the function over here. Or if you want to take derivative marginal ut of t with respect to t, you get 8, and because 8 is bigger than 0, we say that marginal ut of t is increasing in t. Okay. Alright, so now part B, telling you to find a marginal rate of substitution for this utility function. Okay, so we know that the marginal rate of substitution is just going to be the negative of the marginal utility ratio. Okay, so if we take the marginal utility of S divided by the marginal utility of T, now it doesn't matter whether you want to put S on a denominator or you want to put S on a numerator. Okay, it's just going to be either way is correct. Okay, so alright, so in this case I will just put S on a numerator, and that will just give me t squared, so negative t squared 2s divided by s squared 2t. Okay, and so that will just give us negative, so 2 cancel with 2, t squared divided by t will give us t, and s divided by s squared will give us s on a denominator. Okay, so that is the marginal rate of substitution for this utility. Part C, confirm that the indifferent curve associated with utility level 1 passes through the bundle 1 and 1, and that at that point the gradient marginal rate of substitution equal to -1. Okay, so so the indifferent curve associated with utility level 1, so if I equate the utility function u equal to s squared t squared with level 1, so if I equate the utility equal to 1, then this is my function for the indifferent curve. Okay, so any point satisfying this equation is going to be on the indifferent curve that is having a utility level of 1. Okay, so we just have to prove that the bundle 1 and 1 is on this indifferent curve. Okay, so alright, so in order to prove, okay, that the bundle 1 and 1, okay, lies on the indifferent curve with a utility level 1, we just have to prove that the bundle 1 and 1 is basically satisfying this equation over here. Okay, because any bundles that satisfying these equations over here is going to be on the indifferent curve with a utility level of 1. Okay, because we equate the utility level to 1, so we just have to prove okay, it must be shown that bundle 1 and 1, okay, basically satisfy the equation 1, sorry, equation star over here. Okay, now so if you substitute bundle 1 and 1 into here, which is s equal to 1, t equal to 1, it's obvious to see that it's equal to 1, which is satisfy the equation. Okay, so if we substitute 1 and 1 into star. Then we got 1 square times 1 square equal to 1, which is right. Okay, so therefore star equation is satisfied. Okay, so therefore we prove that bundle 1 and 1 belongs to the indifferent curve with a utility equal to 1. Okay, and we want to prove that the marginal rate of substitution at this bundle over here is equal to -1. So we've already found the marginal rate of substitution before. What we want to do is we just substitute the value of this bundle into the function of the marginal rate of substitution and find out the value. Okay, so from the previous part, from B, we have found that the marginal rate of substitution is -t on S. Okay, so now add bundle 1 and 1, which is t equal to 1, S equal to 1. Okay, then marginal rate of substitution is -1 on 1, and that will just give us a marginal rate of substitution of -1. Okay, so part D telling you which if either of the following statements is true. The marginal utility of root S is always decreasing for the utility functions that represent well-behaved preferences. Okay, now if you are looking back at our utility function, in this case it is basically a well-behaved preferences. Okay, it is a utility function that represents a well-behaved preferences. Okay, so is marginal utility of root S always decreasing? Now it's obviously not the case, because we already proved earlier that the marginal utility is increasing. Okay, so it is not true that marginal utility of root S is always decreasing. Okay, so this statement is not true. Okay, because from part A we already proved that marginal utility of root S is increasing. Okay, now statement 2, marginal rate of substitution is always decreasing for the utility functions that represent well-behaved preferences. Okay, so our marginal rate of substitution in this case is -t on S. Okay, is it increasing or decreasing in S? Now, as you can see, whenever S is on the denominator. Okay, so whenever S is increasing, marginal rate of substitution is going to be decreasing. Now, when we talk about decreasing or increasing, we're talking about the absolute value. Okay, we do not care about a negative sign over here, so you just ignore the negative sign. Now, I know that it is confusing, but some cases we do refer to marginal rate of substitution as an absolute value of the slope. Okay, so we do not worry about a negative sign. So sometimes in some definition, marginal rate of substitution is equal to the slope, and in some other definitions, marginal rate of substitution is equal to the absolute value of the slope. So sometimes we have a negative sign, sometimes we do not. Okay, now in the exam we will make sure that we will tell you what we want you to find. Okay, so now if you are unsure, it doesn't really matter. Okay, whether you put a negative sign here or not. Alright, we know that indifferent curve is always downward sloping, so therefore it's always the slope is always negative. Okay, whether the marginal rate of substitution is equal to the slope or equal to the absolute value of the slope, it's really depending on the textbook. Some textbook having a different definitions. Okay, so we do not worry so much about that. So if sometimes, even in our textbook here, in some chapters they say marginal rate of substitution is an absolute value of the slope. Okay, and in some chapters they just say marginal rate of substitution is just equal to the slope of the indifferent curve, that's why we have a negative sign over here. Okay, so please do not worry about this. Okay, now if you have a negative sign or if you do not have a negative sign, you will not get the mark deducted for that. Okay, so but when we're talking about increasing or decreasing, we are talking about the absolute value. Okay, we do not worry about a negative sign, so we're talking about the value only. Okay, so as you can see, when S is increasing, marginal rate of substitution is decreasing, and we're talking about the absolute value. Okay, so do not worry about the negative sign. Okay, so we're saying that marginal rate of substitution is decreasing in S, and so therefore the statement is correct. Okay, now some of you might be wondering, why do we only talking about increasing or decreasing in S? What if I pick T? Okay, so what if I say when T is increasing, marginal rate of substitution is increasing? Now, as you can see from here, my marginal rate of substitution is marginal I take it as marginal UT of S divided by marginal UT of T. Okay, by finding the marginal rate of substitution in this way, I basically choosing S as the variable on a horizontal. Okay, so if I got a little diagram over here just to make it clearer. Okay, so if I got indifferent curve like this, okay, now you do not have to put S over here on a horizontal and T on a vertical. You can just use the other way around. Okay, but remember, marginal rate of substitution is the value of the slope, or the slope of the indifferent curve. Okay, so and it is defined as the ratio of the marginal utility of the good on the horizontal divided by the marginal utility of the good on the vertical, which is T. Okay, so whatever you put on a horizontal, it has to go first over here in the marginal utility to find the marginal rate of substitution. Okay, so it doesn't matter whether you put S here or you put T here, but whatever you choose, it has to be consistent in the way you find a marginal rate of substitution. Okay, so I'm saying it again, if you put S on a horizontal, it has to be marginal utility of S divided by marginal utility of T. If you put T on a horizontal, it has to be marginal utility of T divided by marginal utility of S. Okay, so in this case, because in the previous part I found marginal rate of substitution as a ratio of marginal utility of S divided by marginal utility of T, so therefore S is going to be on a horizontal. Okay, and when we're talking about whether marginal rate of substitution is increasing or decreasing, we're basically talking about how is increasing or decreasing in terms of the horizontal value. So as you can see, as we move along the indifferent curve, so this is the slope of the indifferent curve at this point. Okay, now this is the slope of the indifferent curve at this point, and this is the slope of the indifferent curve at this point. Okay, so as you can see, the slope is getting the slope of the tangent is getting smaller and smaller, become flatter and flatter as we move along the indifferent curve. Okay, so therefore we are saying that the marginal rate of substitution for a utility that represent well-behaved preference is going to be decreasing, or we have a diminishing marginal rate of substitution. So as we move along the indifferent curve, the marginal rate of substitution is getting smaller and smaller. As you can see, the tangent is getting flatter and flatter. Okay, so the slope is getting smaller and smaller or the marginal rate of substitution is decreasing in S. Okay.